Today our lesson is on parts of a radical. So it says the nth root of a number, a, can be written as a radical expression that looks like this. Okay, so if we look at this in detail, that little n is the index. So if I say it has an index of 2 or 3 or 4, that's what this number is going to show right here. This square root is a radical. So you've seen the square root before, I'm sure. That's called a square root or a radical. Okay, there's two names for it. And this number inside is called the radicand. So index, radical, radicand. So if there's no index, so if there's none of these, so if this doesn't exist right here, if there's nothing there, it's assumed that n equals 2. So if this n, if that's gone, like for example, if you look on number 2, see how there's nothing there? That means that there's a 2 there. It's just assumed that it's 2. If a radical has more than one root, the radical sign indicates only the principal or positive root. Okay, so list the first 12 perfect squares. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, you see the picture, so and so on, 36, 7 times 7, 8 times 8, 9 times 9, 10 times 10. Those are the first, actually, those are not the first 12, I'm sorry, those are the first 10 perfect squares, but we're just going to leave it like that. Okay, so if we take a look at number 1, the square root of 81, what that means, first of all, there's a 2 there, isn't there? Because remember up here, we said that if there is no index, then it means that it's 2. So this is an automatic 2. I'm only going to write it for the first 2 problems. You just need to remember that there's a 2 there if there's nothing there at all. Okay? So this just means, technically that 2 means what times what equals 81, equals that number inside. So what two numbers of the same numbers give us 81? Well, 9 times 9. So the square root of 81 equals 9. Okay, there's an automatic 2 on this one, even though it's not showing there. So that just means, again, what times what equals the number inside, equals 484. Well, there's a square root button on your calculator. So if you take your calculator and you push the square root button, so take a look at your calculator and push the square root button and type in 484, you're going to see that 22 is your answer. That means that 22 times 22 equals 484. So your answer here is 22. Okay, number 3, square root of 64, that's 8. So now if we have something that looks like this, we're going to do the square root part first, and we're going to multiply it by the outside, because this is saying 18 times the square root of 4. We know the square root of 4 is 2. So that just means 18 times 2, which is 36. Same thing here. Take the square root of 256 on your calculator, and then multiply it by 3. So it's 3 times 16, which is 48, because the square root of 256 is 16. So 3 times 16 is 48. Okay, this just means negative 5 times whatever the square root of 121 is. Well, the square root of 121 is 11, so negative 5 times 11 is negative 55, and that's your answer. So when you have fractions, you're going to divide, you don't have to, but you can think about it as separate. So the top is separate and the bottom is separate. Both of these mean the same thing. So if you don't want to write it out like this, you can just think of it separately. So the square root of 1, well, what's the square root of 1? What times what equals 1? 1, right? So we're going to have 1 on the top. And then what's the square root of 16? 4. So 1 over 4. Number 8, square root of 9 over square root of 100. So the square root of 9 is 3, and the square root of 100 is 10. Again, put this in on your calculator, not the whole fraction, but put it in separately. Square root of 9 is 3, and then take the square root of 100, which is 10. Okay, let's look here. That's going to be the square root of 25 over the square root of 49, which means the square root of 25 is 5, and the square root of 49 is 7, and that's your answer. Okay, so now we're going to find the largest perfect square. If it doesn't go in evenly, if your perfect square, if this is not like, if you put this in your calculator, it's going to give you a decimal. Anytime it gives you a decimal, these are the steps we need to follow. First, we need to find the largest perfect square. That the radicand, remember this is the radicand, that number underneath. So find the largest thing that it can be divided into. Then take the square root of the perfect square and leave the leftover under the radical symbol. So if this is confusing, we're going to do some together. So square root of 24, first of all, I'm going to write out all of the perfect squares because it says to find the largest perfect square. And that's a key word, is the largest. So we're not going to stop necessarily when it divides in evenly. We're going to keep going. So like, for example, obviously if I'm going to divide 24 by the first perfect square, you do not need to divide it by 1 because it's just going to be the same number. Okay. But let's start here. If we divide 24 by 4, that's 6, right? So that's going to be, there's nothing greater than that we can divide by here. So it's going to be the square root of 4 times the square root of 6. Now, if you're not sure, do 24 divided by 9, 24 divided by 16. All of these, the 9 and 16 do not go into 24. So I know I can stop here. And my answer is going to be square root of 4 times the square root of 6. Think about it this way. Doesn't 4 times 6 equal 24? So square root of 4 times the square root of 6 equals the square root of 24. That's how we break down this square root. Now the square root of 4 equals 2. And the square root of 6 doesn't equal anything. If you put that in your calculator, that's a decimal. So that's how your answer is going to look. 2 times the square root of 6. Okay. So obviously we don't have to do divided by 1, but I just wanted to show you. So 48 divided by 1, I'm showing you we're dividing it by we're dividing this number by every single one of these perfect squares. 48 divided by 4 is 12, which is great, but I'm going to see if there's anything bigger. 48 divided by 9, which is the next one, is 5.3. So I know for sure that one doesn't work because I can't have a decimal. 48 divided by 16 is 3. Okay, so that actually looks like that's going to be my answer. Again, if you're not sure, do 48 divided by 25 and 48 divided by 36. You never have to divide this number by a number greater than this, because that just doesn't make sense, right? 48 divided by 49, 48 divided by 64. Now that's going to be decimals. So when you're dividing this number under the radical sign, always divide by something less than it. So you can check all the numbers less than it, and whichever one gives you, whatever number divides, that's the highest. So like 4 gave me a perfect number without a decimal. 16 also did. So since 16 is highest, I'm going to use this. And I'm going to say square root of 16 times square root of 3. Square root of 16 times square root of 3, because again, 16 times 3 is 48. Square root of 16 is 4, but square root of 3 doesn't, there's nothing, so it's just 4 square root of 3. Okay, 72. I'm going to skip 1 from now on because there's no point in dividing 72 divided by 1. 72 divided by 4 is 18. Let's see if there's anything higher. 72 divided by 9 is 8. Okay, let's try some more. 72 divided by 16 is 4.5. 72 divided by 25. Again, you're just putting these in your calculator, so we know those two aren't going to work. 72 divided by 36. Oh, there's 2. Okay, so that looks like that's for sure going to be the highest answer that we can divide by without a decimal, right? So I'm going to use square root of 36 times the square root of 2. Square root of 36 is 6. Square root of 2 stays there because we cannot simplify that. Okay, try 13 and 14. I'm going to do 15. So 175, again, I'm starting with this, divided by 4. that's a decimal, so we can cross that off. Divided by 9, that's a decimal. Then we're going to try divided by 16, because that's our next perfect square. Again, that's a decimal. Then we're going to try dividing it by 25. It's 7. And since 7 is, since this looks like the biggest to me, but you can keep going if you're not sure. I was sure that we stopped here, but if you're not sure, please keep going until you are sure that this is the highest answer you can divide by without it being a decimal. So square root of 25 times square root of 7, that's 5 square root of 7, and that's your answer. Okay, so let's try these. Now, these are not, oh no, this is the same thing. Okay, sorry, I didn't leave the directions on this end. I don't know why I didn't put the directions up here. So 162 divided by 4, again, we're just dividing by our perfect squares. That's a decimal, so we can't do that. Divided by 9 is 18, but let's keep going to see if there's anything else that works. Okay, none of these, all of these are decimals, right? But if we divide by 81, look, I got a 2, right? So do you see how all of these were decimals? So none of these worked because they're all decimals. But I ended up getting a 2, that came out evenly. So now I know I can split this up into the square root of 81 times the square root of 2. Square root of 81 is 9 times the square root of 2, and I'm going to erase all that. Okay, 245. Divide by 4, that's a decimal. If I divide by 9, that was a decimal. If I divided by 16, that was a decimal. 25, decimal. 36, 49. Okay, cool. So I got 49. I finally didn't get a number that was a decimal, so I know this is going to break down into the square root of 49 times the square root of 5. So 7 square root of 5. Okay. Try those 4 and see how you do. So now we're going to list the first 10 perfect cubes. A perfect cube is 1 times 1 times 1. 2 times 2 times 2. 3 times 3 times 3. Okay? So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Makes sense? 5, 6, 7, 8, 9, and 10. So those are the first 10 perfect cubes. So if we look at number 22, we're going to say, okay, that 3 right there, that means, remember when 2, I said what times what equals that number? Well, now we have 3. So what number times what number times what number equals 8? Well, we know that that's 2 times 2 times 2, so the answer is 2. Now, just like how on your calculator you have a square root button, you also have a cube root button. So a cube root button, I'm going to show you guys how to put that on your calculator. So when you type this in, you'll be able to literally type in the cube root, push 8 equals, and you'll get that number. So if you do the same thing here, all that 3 means is what 3 numbers multiply together to equal 729. 9 times 9 times 9, so your answer is 9. So again, we're literally putting these in on the calculator. If I put try 24. If I put the -1 and I take the cube root, your answer is actually going to be -1. The reason for that is because here, -1 times -1 times -1 equals -1. Okay, so we actually can have a negative under a cube root, but not a square root. So here, if you have that 3 and you're taking the square root of -343, if you put that in your calculator, you're going to get -7 for your answer. So try 27 and see what you get. Okay, last part, simplifying square roots. So use the same method to simplify square roots that you did to simplify square roots. However, use the perfect cubes to break down the radical. So I'm going to write down the perfect cubes again because I don't have it on this page. And then I'm going to divide again, just like I did with the square roots, but this time it says that 3. So I need to divide this by all of my cube roots. So I'm going to try doing 40 divided by 8 first because that's my first cube root. Remember, if this comes out as a decimal, just like for the square roots, we need to find the largest perfect cube that goes into it. So if it comes out of a decimal, like if we were to divide this number by 8 and it was a decimal, we need to move to the next number, to the next number, to the next number. Okay? So let's do 40 divided by, okay. So if we take the cube root of 40, that's going to equal 3.419. If you put that in your calculator and it comes out as a decimal, that's when we know we need to start dividing by these perfect cubes. So we know that that doesn't work. So we're going to say, okay, 40 divided by 8, because that's my first perfect cube after 1. 40 divided by 8 is 5. So I'm going to split this up into the cube root. See that little 3 this time? We didn't need to write the 2 for the square root, but we need to write that 3 for the cube root. So we have cube root of 8 times the cube root of 5, and that equals the cube root of 40. What's the cube root of 8? If you put that in your calculator, that equals 2. And then the cube root of 5, you just leave it like that because it comes out of it as a decimal. So we have to leave it the cube root of 5. Okay, let's try 29. If we divide it by 8, we get a decimal, so it doesn't work. Our next cube root is 27. If we divide it by 27, we get a decimal, so that doesn't work. Let's try dividing it by 64. That doesn't work. 125. Okay, so it came out as a 4, so there's no decimal, so this breaks down into square root of 125 the cube root of 125 times the cube root of 4. The cube root of 125 is 5 times the cube root of 4. You can't do anything. That comes out as a decimal, so we'll just bring that down. Okay, 162. I want you to try that one. Number 31. Again, we can have a negative inside of the square root. So let's do negative 16 divided by 8. That goes in evenly, right? It doesn't come out as a decimal. So I'm going to break this down into the cube root of 8 times the cube root of 2, which is 2 cube root of 2. And you see that negative? When we have a negative inside the square root, the cube root, we need to bring that down. So if it's a negative under the cube root, we're going to make it a negative on the outside. It's a negative 2 cube root of 2, and that's your answer. Okay, so for this one, I skipped all the steps here. I divided by 8, 27, 64. I kept going until I found the biggest number that I possibly could, and I found out that 432 divided by 16 equals 2. And then I just said, okay, well, the cube root of 216 times the cube root of 2. Cube root of 216, if you put that in your calculator, is 6 times the cube root of 2. Okay. Cube root of 64 times the cube root of 5. Again, all I did was divide this by 8, 27, 64. I got an answer for 64. So I said the cube root of 64 times the cube root of 5. The cube root of 64 is 4 times the cube root of 5. Remember, it's a negative, so I'm going to bring that negative down, and that's your answer. So I want you guys to try these last 3.